we really focus within next generation core services, right? Your call routing for 911. Our huge focus is on availability, obviously. Like calls got to get through. And so as part of that, we also look at how we want the system to fail, and how we want to plan for the system to fail and still be able to provide full service and full function, and even completely fail and still have that call get through around us if necessary. And so to that end, you get into, you start with routing plans, right? How the calls are flowing, and then you have a routing plan for in case you're completely out. Those calls still get delivered. And then you get into, okay, what are we building? We're building 2 data centers. We want to build it so either data center can just go away. Each data center is connected to 2 networks. Again, any network can just go away. Within each data center, you have 2 racks, so you have an A and B structure. And what are they? They're set up so that any rack can just go away, right? So you're structuring this so that you have the maximum availability, but then you get into, okay, how does all this talk, right? Because a lot of structures do this, and this is, we're not setting the world on fire with any of this brilliant stuff, but then you get into something that really becomes a value add. How does this all talk to itself? So traditionally, this would function as a single unit. And it would communicate, it would communicate state to itself. It would be this great self-healing, self-replicating, self, until something unexpected happened. And then if something unexpected happened, either somebody fat-fingered something or just some unexpected input or output, the entire system could be vulnerable and could crash from one input, one fault. Well, that can't happen because the coordination system won't allow it. Well, it's the coordination system that crashed it, right? And this is super common in most designs, is that you've got multiple units of function with an overarching system that coordinates that. What if that system fails? You only have one of them. And so what we're building are systems that have failure domains. And so you now have data center, right? And you have a failure domain between them that says, we don't want them talking. We only want them talking in a very specific, restricted manner so that no matter what happens at this data center, the other data center can't be affected. So if this data center freaks out, old school broadcast storm, right? New school, it freaks out in some creative way that jams the protocol stack, whatever. That system just dies. Other system continues to provide function. Phone calls come in, phone calls go out, load is serviced. And so we're really getting very deep into this failure domain concept and having intentional discontinuities between different units of function so that you cannot have kind of a cascade failure that kind of chains through this system and dominoes you down. And it takes getting used to as a concept. Because in essence, instead of creating one system to service this load, you're creating 2 systems, either one of which can service the load. And the way that we typically would deploy it, we will request the OSP to load balance between the 2 systems. And then the real challenge for us is making sure that if a system becomes crippled or unable to properly function, that it just turns off. And so now that it's just turned off, OSP can't see it, OSP directs the calls to us at the surviving location. So it's very different. It is not typical. It is an industry first, but it's very much a value add.